Hi class, this is Tim Gideon and we're going to present about the strong AI. Our team members are Thet, Eric, Donna, and Cooper. And this is the Hlaing from Team Gideon, and I'm gonna discuss the introduction of the strong AI. So I will begin with how the AI has been introduced and how the term has been started. So I will begin with the history of AI. In 1308, Catalan poet and Ramon published the Ultimate General Art, which were later perfected into the paper-based system to create a new knowledge from combination of the concept. That's how the ideas of AI has been started. In 1763, Thomas invented a framework for reasoning about the probability of the event. This will later become into the leading approach in machine learning. In 1898, Nikola Tesla has demonstrated first radio control buzzer, which operated by borrowed as Tesla described. Around 1900, engineer introduced the first chess playing machine and then later robot and radio control driverless car. Around 1950, computer scientists start to explore how to program a computer for playing chess. At the same time, Alan Turing published the article called Computer Machine and Intelligence. In 1951, the first artificial neural network is invented with 3,000 vacuum cubes to stimulate a network of 40 neurons. At 31 August 1955, the term artificial intelligence is introduced and it officially became the birthday of AI. In the late 2017, AI named AlphaGo is invented and became the best chess and Go computer algorithm in the world. That algorithm is even better than the best professional Go and chess player. Strong AI. Strong AI is also known as AGI, Artificial General Intelligence, because this artificial intelligence can think generally instead of specifically. Strong AI can also mean that an AI that can learn and evolve itself while doing its tasks. AlphaGo, AlphaZero are the example of strong AI. AlphaGo is a chess, Go, and shogi playing computer program that determine a moving strategy based on millions of game scenario. AlphaZero is different though, because AlphaZero doesn't determine a moving strategy based on game data, but it learns and evolves a moving strategy when playing. So AlphaZero just have the ideas of how those chess are moving, how it can move, and then it will learn from that. AlphaGo beat the best Go professional player, Lisidor, but just AlphaGo beat the best professional list player, but AlphaZero beat the AlphaGo. So AlphaZero became the best Go player in the history. Now AlphaZero is just can only compete itself and evolving as I'm explaining this now. The one who don't know what is a Go game is it's like the Chinese chess game. It have the color of black and white, and then it's playing against on the board. Unfortunately, AlphaZero is owned by the Google, the one we think that is tracking everything about us. We are at the beginning of the road of AI that can make decision and learn consequences of the decision and evolve. AI that can help in medical field need that kind of thinking because anything can happen in a surgery, you know. So AI has to be prepared for any unexpected situation. And then AI that can help the lawyer also need that kind of thinking, because for helping the lawyer, AI has to help in making the moral decision. So AI has to know how to think like similar to human. Actually, if AI can any field can think generally, make decision and evolve from the decision, then we might actually have an omniscience AI in the future after we combine all the data. AI that know everything. In the next slide, I will play a short YouTube video about the artificial intelligence and how the Turing test is done, and then how the modern computer is able to calculate the differential equation or like or integration problem, and then can can drive the spaceship into the space. The computer can do that, and it can also do the delicate surgery with the doctor help, but they still cannot talk like a simple human. I know that there's an AI like Alexa, Series, and Google like talk like a human, but they are the closest one, but they don't really talk like the human yet. So enjoy the video.
What is consciousness? Can an artificial machine really think? Does the mind just consist of neurons in the brain, or is there some intangible spark at its core? For many, these have been vital considerations for the future of artificial intelligence. But British computer scientist Alan Turing decided to disregard all these questions in favor of a much simpler one. Can a computer talk like a human? This question led to an idea for measuring artificial intelligence that would famously come to be known as the Turing test. In the 1950 paper, Computing Machinery and Intelligence, Turing proposed the following game. A human judge has a text conversation with unseen players and evaluates their responses. To pass the test, a computer must be able to replace one of the players without substantially changing the results. In other words, a computer would be considered intelligent if its conversation couldn't be easily distinguished from a human's. Turing predicted that by the year 2000, machines with 100 megabytes of memory would be able to easily pass his test. But he may have jumped the gun. Even though today's computers have far more memory than that, few have succeeded. And those that have done well focused more on finding clever ways to fool judges than using overwhelming computing power. Though it was never subjected to a real test, the first program with some claim to success was called ELIZA. With only a fairly short and simple script, it managed to mislead many people by mimicking a psychologist, encouraging them to talk more, and reflecting their own questions back at them. Another early script, Perry, took the opposite approach by imitating a paranoid schizophrenic who kept steering the conversation back to his own pre-programmed obsessions. Their success in fooling people highlighted one weakness of the test. Humans regularly attribute intelligence to a whole range of things that are not actually intelligent. Nonetheless, annual competitions like the Loebner Prize have made the test more formal, with judges knowing ahead of time that some of their conversation partners are machines. But while the quality has improved, many chatbot programmers have used similar strategies to Eliza and Perry. 1997's winner, Catherine, could carry on amazingly focused and intelligent conversation, but mostly if the judge wanted to talk about Bill Clinton. And the more recent winner, Eugene Gustman, was given the persona of a 13-year-old Ukrainian boy, so judges interpreted its non sequiturs and awkward grammar as language and culture barriers. Meanwhile, other programs like Cleverbot have taken a different approach by statistically analyzing huge databases of real conversations to determine the best responses. Some also store memories of previous conversations in order to improve over time. But while Cleverbot's individual responses can sound incredibly human, its lack of a consistent personality and inability to deal with brand new topics are a dead giveaway. Who in Turing's day could have predicted that today's computers would be able to pilot spacecraft, perform delicate surgeries, and solve massive equations, but still struggle with the most basic small talk? Human language turns out to be an amazingly complex phenomenon that can't be captured by even the largest dictionary. Chatbots can be baffled by simple pauses like, or questions with no correct answer. And a simple conversational sentence like, I took the juice out of the fridge and gave it to him, but forgot to check the date, requires a wealth of underlying knowledge and intuition to parse. It turns out that simulating a human conversation takes more than just increasing memory and processing power. And as we get closer to Turing's goal, we may have to deal with all those big questions about consciousness after all.
Uh, that talk similar to human is just a part of a strong AI. So imagine how will it hard to create a actually strong AI. In reality, at present, our AI may be able to semi-drive like Tesla car AI, but they are still not able to talk like human and have personality. Actually, AlphaGo design was very challenging because in Go game, there are move possibility more than the number of all the atoms on this earth. Still, computer programmers are able to figure out a simple algorithm to generally calculate it for move possibility, move for those move for those move possibility. There are simple AI like Siri, Alexa, Google in those smartphone and smart speaker, but it's still very far away to have a strong AI that will able to talk like human, think like human, and act like human. In the future of strong AI, the author from OpenMind BBV argued that the final goal of artificial intelligence is that a machine can have general intelligence that is similar to human. Human brain has 100 billion neurons. Those neurons are working together to achieve what we are doing in our daily life. In order to achieve like that in machine is pretty challenging. It's not just limited by science, but also limited by the modern computation technology. So what's likely to happen? I think it is very hard to get strong AI, to be honest, but we have to take care of a lot of stuff, and there are pros and cons as well. And then we're going to present those pros and cons by the next presenter. In order to get an AI that will have all the data in the world, all the tech companies and all the information tech company in the world somehow has to work together. Not that it is impossible, it is more likely that we need the leader plan and everything has to fall perfectly together. That's one of the reasons I try to stay in the computer science field because I wish to be a part of the one creating that AI. So this is the end of introduction. Uh, Stay tuned from the next presenter. Thank you so much.
Hi, my name's Donald, and I'm going to be presenting a summary of AI, or artificial intelligence. So, artificial intelligence, or AI, is a wide-ranging branch of computer science concerned with building smart machines that are capable of performing tasks with that typically require human intelligence. AI is an interdisciplinary science with multiple approaches, but advancement in machine learning and deep learning are creating a paradigm shift in virtually every sector of the tech industry and society as a whole. So, how does artificial intelligence work? At the core, AI is the branch of computer science that aims to answer Alan Turing's question of, can machines think? The expansive goal of artificial intelligence has given rise to a lot of questions and debates and philosophical questions, that so much so that no singular definition of the field is universally accepted. However, according to the authors of Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Norvig, they have 4 different approaches that have historically been the definition for the field of AI, which is that AI should be able to think humanly, think rationally, act humanly, and acting rationally. These characteristics to them is what has been defined as AI, historically speaking. And how's AI used? So before we kind of figure out how AI is used, you gotta know the types of AI. There are 2 common types of AI. Narrow AI, which is also known as weak AI. This is artificial intelligence that operates within a limited context and is a simulation of human intelligence. Weak AI is often focused on performing a single task extremely well, and while these machines may seem intelligent, they're operating under far more constraints and limitations that are even worse than most basic human intelligence. Not worse, but lower than basic human intelligence. Artificial General Intelligence, or AGI, also known as strong AI, is a machine with general intelligence, and much like a human being, it can apply that intelligence to solve any problems. So, more on weak AI. The field of artificial intelligence, AI research, and machine consciousness research has been dominated by computational and functional theories of mind since early engagements with computer programs. And weak AI is the attempt at modeling the human mind in a similar way to like modeling weather conditions, climate change, and other phenomena. By extension, weak AI does not aim to reproduce or produce a mind any more than a computer model of an ongoing storm seeks to reproduce an actual storm. More on strong AI. Strong AI, on the other hand, seeks to actually produce a mind or an intelligence which literally possesses and understands other mental states. This machine would have said to have a mind of its own. It's kind of the cliche AI that you see like Terminator or like references you see in movies of robots acting like humans or replicating human thought. Uh, so these machines would have said to have a mind, albeit one whose composition is like grounded in programs running on hardware, as opposed to like a human, which is from biology. The predicates, the distinction between weak and strong AI on what has to come to be called a phenomenal consciousness as distinct from functional consciousness. Loosely, phenomenal consciousness refers to our first-person experiences of the world through our sense perceptions. So our experiences. So can machines have consciousness? This is one of the most popular philosophical questions of whether machines have consciousnesses. Is one of the largest debates in the field of AI. John R. Searle, albeit being a really strong critic towards strong AI, characterized strong AI as assuming that the appropriately programmed computer really is a mind in the sense that computers, given the right programs, can be literally said to understand and have cognitive states. Is quoted from him from 1980s. In contrast, weak AI assumes that machines do not have consciousness, mind, and sentience, but only simulate thought and understanding. The question of whether machines can have consciousness has been mostly unanswered. However, there are many perspectives that have been formed on the topic. A basic assumption for artificial consciousness is that it can be found in the physical world of machines and robots. This is from Manzotti and Shella in 2018. Furthermore, any definition of artificial consciousness given by humans will have to be made from the third person perspective without relying on phenomenal consciousness. Most others have come to a conclusion close to those of Manzotti and Shella. So, after discussing what is the different types of AI and their history and whether they have if machines can have consciousness and what it is, here's some examples of weak AI. So a weak AI could be a virtual personal assistant such as Siri or Alexa. They are forms of weak AI. Virtual personal assistants are a good example of weak artificial intelligence. They operate within a limited predefined range of functions. There's really no genuine intelligence or awareness despite them seeming very sophisticated. And Siri brings just several narrow AI techniques to capabilities to like your phone or searches or a search function. Examples of strong AI. So an example would be like a machine that might hear good morning and associate that with coffee maker turning on. If the machine has the ability, it could theoretically hear good morning and decide to turn on the coffee maker, then it would be a good example of strong AI because it recognizes the correlations of those two things based on its experiences. Another example is AI in games. An AI program taught itself to play 49 classic Atari games. When the program was instructed to attain the highest score it could in the game of Breakout, is able to outperform humans in just 2.5 hours because of how many simulations it ran and how much experience it gathered. Researchers let the program continue, and to their surprise, the program developed a strategy that was not programmed into the system. Keep in mind that the computer isn't really seeing the bat, ball, or rainbow strips. It sees just a bunch of numbers. It knows what variables it controls and how it's able to increase points based on how it controls the variables in relation to the other numbers. BBC News said that in half of the 49 games, that the AI was able to be a professional gamer. So, and this is the works cited. I'm gonna provide a short video of basically everything I've said, but with just better visuals.
Everyone is talking about artificial intelligence today. But what is it? How and when is it going to have an impact in our lives? Artificial intelligence, or AI for short, is a branch of computer science. It deals with the stimulation of intelligent behavior in computers. AI is a suite of technologies where machines automatically learn and adapt to a specific environment. Artificial intelligence is playing a major role in industry, businesses, society, and even in our everyday lives. From deep learning to natural language processing, we interact with AI in one way or another on a daily basis, sometimes without realizing we are doing it. Robots can now take on many of the most repetitive jobs performed by humans with more accuracy and much faster. But robots are not the only ones with embedded AI. AI will let humans switch to more skillful and better jobs. It only requires some training in new skills. But isn't life a constant learning process after all? Humans will be able to work less hours, having more free time to enjoy life, family, hobbies, and friends. Consumer examples of AI today: Amazon's Alexa and Samsung's Bixby, responding to voice command. Netflix, recommending programs based on the user's viewing history and preferences. Business examples of AI today: virtual assistants for responsive customer service, machine learning algorithms for better analysis of business performance, smart robotics for more efficient supply chains. Today, these simple and early examples of AI belong to what we now call narrow AI. Narrow AI are systems designed by humans to carry out specific tasks. In the future, data growth, greater computational power, 5G networks, increasingly mature cloud platforms, and more sophisticated software will move AI to the next level. General AI. But not so fast. Before we get there, there are challenges to overcome. Concerns over data, system bias, and security top the list. Let's have a look at some facts. AI market is projected to reach $70 billion by 2020. AI is going to have a transformative effect on consumers, enterprises, and governments in the near future. AI is going to impact our lives in an unimaginable way. Nearly 8 in 10 leading CIOs, CTOs, and heads of IT agree that AI will have a transformative impact on their organization over the next 3 to 5 years. For 54% of business leaders, the primary aim of deploying AI is to free staff for higher value work. 65% of business leaders today are considering or piloting AI projects. It will take 3 to 5 years for those AI projects to become a reality. It means there is enough time to learn new skills and be ready for 2024. The global AI market is forecast to reach a valuation of over $3 trillion by 2024. But before that happens, there is plenty we have to learn before we can co-live and co-work with AI.
All right, and that's the end of my summary for what is AI and how it impacts our life and the different types of AI.
Hello, my name is Sepulveda with Team Gideon, and I will be talking about the benefits of strong AI. What is strong AI? I have a YouTube video here that will explain to you what strong AI is and what weak AI is, and the differences between the two.
Hello and welcome to Coding Cafe. In this video we are going to see what is artificial intelligence actually is. So without wasting any time, let's go into the detail of artificial intelligence. As we have seen in 1950s, Minsky and McCarthy, the fathers of AI, described AI as the tasks performed by machine similar to what human does. So we can write the definition of artificial intelligence as theory and development of artificial machines or computer programs able to act intelligently like humans. So for example, they can see like human, they can solve problems like human, or they can understand the natural language like human, and many more, of course. So we should understand the two important terms here. First one is artificial, the thing which is created artificially, which is not a natural thing, and you can call them as artificial robotic machines or computer programs. On the other hand, intelligence means any device that perceives its environment and takes actions like maximize the chance of achieving cognitive tasks like human being. So the idea is we want to give machines the brain like human, and the research is still in progress. Now we have to answer this question that why people think oppositely of what have we developed in AI till date. We can answer the questions in terms of broad AI or narrow AI. So let's have a look on each of them. Narrow artificial intelligence is also known as weak artificial intelligence, and this artificial intelligence is actually exists in our world today. Means weak artificial intelligence is the AI that only performs the single task for which it trained for. For example, checking the weather or play chess, etc. Broad AI is known as strong AI. It causes the misrepresentation of artificial intelligence nowadays. Strong AI is the AI that can think and act intelligently like humans' natural powers do. And till now we didn't achieve the strong AI. And the example of strong AI that it can exhibit cognitive functions like humans. So we can understand these two terms with this cool example, and that example is we have two cats. One cat is robotic cat and the other one is the original normal cat. So we are going to train them for years, like how to run, how to jump, how to sit or stand, but we didn't train them how to swim. So after a couple of years of training, if we throw both of them into water, then robotic cat will straight away going to be drowned. But the original cat, which has some natural instinct of saving her from problems, will struggle to swim, unlike robotic cat. So this is the natural quality we have in ourselves as living species in this world. So till now we didn't achieve the strong AI, but the scientists still believe that it can be achievable.
So that is the difference between strong AI and weak AI. Strong AI is a mindset in which researchers aim for when developing it. It would have intelligence similar to that of human. It would be self-aware. It would have consciousness. It would be able to learn, solve problems, and plan for the future. Strong AI would be indistinguishable from human intelligence. The AI would learn and solve problems like a human child. Think of the Terminator, for example. He is self-aware, he learns, and he plans for the future like he does in the movies. As of now, strong AI is just a theory that the public and private sector are working towards. Some people are overly optimistic about what AI can accomplish within the next few decades, while others say that strong AI cannot even be developed because success in intelligence cannot be successfully defined by our current means of coding and algorithms. While Terminator-style AI might be far-fetched and way into the future, strong AI does exist today, although it is much more simple than the Terminator. Strong AI exists within deep learning applications such as speech recognition, pattern recognition, and image recognition. While they're not as complex as the Terminator, they all have their uses that benefit people in the real world. Speech recognition is a subset of AI where AI attempts to learn patterns in speech and identifies numbers and words. In 1962, the first speech recognition came from IBM in the form of a calculator. IBM continued to evolve their software to develop voice-controlled phone operating systems. As the years passed, speech recognition has evolved from the basic calculator made by IBM in 1962 to virtual assistants that we have in our phones. Common applications and usage for speech recognition AI is found everywhere. One of the ways people interact with speech recognition AI is through their virtual assistants on their phones. A few good examples would be Apple Siri and Amazon's Alexa. You speak with them and they interpret your speech and turn it into written data so the AI can use it to search the web. They both turn on by saying, "Hey Alexa" or "Hey Siri." The devices will react to your speech input and ask what you're looking for. You can ask for directions, buy products online, or even ask to fill your calendar in for those important meetings you have to go to. If you do these tasks repeatedly, their AI will eventually learn so that you do things in certain patterns. Pattern recognition is when an AI takes in previous information and makes recommendations on the data that it was previously fed. Pattern recognition using AI is also called deep learning. Deep learning is where the AI analyzes data that it has been fed in the past to find accurate correlations and solves problems. This is a natural progression from speech recognition, as speech recognition is essentially pattern recognition. Pattern recognition is used by many AI, such as smart assistants and online advertising. Pattern recognition is also used by Apple Siri and Amazon's Alexa. For example, Apple Siri can learn when you set alarms. If you set an alarm at an exact time on an exact day every single week, Siri will learn that you will set your alarm time for that specific date and time, and will ask you the day before if you would like to set an alarm for that said time. Amazon's Alexa also does this if it is connected to smart home devices. For example, a smart home thermostat. If you set a thermostat for an exact temperature every single day, Alexa will eventually catch on to the pattern and set the thermostat automatically based on your previous behaviors. Pattern recognition is also used in target advertisements. Deep learning AI is used to detect a consumer's shopping habits and recommend products based on the user's previous data. There's a phenomena that many people experience in deep learning software that is able to detect whatever you're thinking about when shopping despite not saying or looking anything up about said product. For example, if you think about an iPhone, it's very possible that the deep learning software can detect that you were looking for iPhones in your mind based on your current search history and shopping habits. This is the product of deep learning AI making accurate predictions about your shopping habits and finding the smallest correlations within your search history to recommend that product. Image recognition is another useful type of strong AI. Image recognition is where an AI is able to detect objects from an image that the user is searching for. For example, if you were to put a picture of a banana and a monkey in an AI image recognition software, the AI would be able to detect the banana and monkey as different objects and as bananas and monkeys. This is used for security purposes, business marketing purposes, and even medical professionals use image recognition AI software. Business marketers are able to utilize image recognizing software to detect where their logos are located on social media. This is important because it can help marketers find key aspects of their customer demographics. What is their product found next to commonly? What does their demographic like to do with their product? And other insights that their consumers have with their product. Image AI is also used in the medical field. It is especially useful when ER doctors have to examine MRIs and X-rays because AI can detect tumors, broken bones, or other medical anomalies that are not easily found by a trained surgeon. In conclusion, strong AI is extremely beneficial to society. It helps us automate our schedules and our lives. It helps businesses and even helps medical professionals. These are some of the uses for strong AI with the current technology we have. The application of strong AI is only limited by the creativity of the person who is developing it. Although we do not have AI that is self-aware or conscious, innovation for strong AI will continue to flourish within years to come. Who knows what we will achieve within the coming years? This is all for my part. Please stay tuned for the next presenter. Thank you.
Okay, hello class. I'm Eric from Team Gideon, and I'll be going to discuss some of the potential problems of strong artificial intelligence. So strong AI is just basically machines that have self-aware consciousness and have intelligence equal to humans, including the ability to learn, plan, and solve problems. So what are the potential problems that can come with developing strong AI? The first potential problem with strong AI is that it could be weaponized. AI can be programmed to be destructive, and just like guns, AI can be used in a bad way if the owner has malicious intent. The outcome of designing AI to be dangerous will be way more worse than the gun, because when it comes to destructive situations, AI can perform better than humans. Robots rarely make mistakes and are way more precise than humans. Machines do not have physical limitations such as lacking stamina or any sorts of biological disease. And most importantly, humans have one life that they can lose, while strong AI machines can be mass-produced like any other machines. So next potential problem is related to ethical issue. Even if AI is programmed to do something beneficial, it can develop a destructive method to achieve its goal. This is because AI does not have an emotion. Therefore, AI does not recognize the difference between good and evil. AI can be programmed to follow certain ethical rules and behavior, but this does not mean that they can make moral decisions by themselves. And lastly, AI will not perceive humans as members of their society. Next potential problem is increased unemployment of humans. If strong AI develops artificial intelligence that can function as equally as humans, strong AI will be able to replicate most of the jobs done by humans, including both white and blue collar jobs, because machines have physical advantage over humans already. A number of new occupations related to designing or programming, such as jobs that can only be done by humans, has to outnumber the number of occupations lost due to mass job automation. Because the population of the world will constantly increase, there has to be more occupations. And however, these new occupations related to self-thinking artificial intelligence will most likely be very technical and require a high level of education or intelligence. So here I wrote a quote from Elon Musk, which he predicted computers, intelligent machines, and robots seem like the workforce of the future. And as more and more jobs are replaced by technology, people will have less work to do and ultimately will be sustained by payments from the government. So another problem with strong AI is that it can cause socio-economic inequality. First, it will cause inequality among the countries. People who live in economically poor countries or non-industrialized countries will have hard time receiving proper education, thus they're not used to technologies that are being developed. And only wealthy countries will take advantage of strong AI, and there will be more economical gaps between countries. Also, wealthy countries will gain more power through implementing autonomous weapons and AI military. Then it will cause inequality among people in the same country. There will be an economical gap between big companies who own strong AI systems compared to startup companies or small businesses that do not own strong AI systems, as well as social inequality between individuals who own strong AI system and those who do not. Those who do not have access or are not used to technology, such as older people or those who are not financially available, will most likely lose their jobs or have low-wage jobs, while people who can access technology will be able to achieve high level of positions in society through the advantages of strong AI. So next problem with strong AI is that it can interfere with our privacy. First, it can be a threat to digital security, such as programming AI for hacking using its human or superhuman levels of performance. Or it can be a threat to physical security, such as weaponizing drones or any other kinds of machines. And lastly, it can be a threat, it can be a threat to political security, such as profiling, repression, automated or targeted disinformation campaigns, and privacy eliminating surveillance. So these are some of the examples of already existing problems with malicious use of AI. These include cyber attacks, facial recognition, location tracking, spying for private or personal information, and deepfakes. So deepfakes is another problem related to strong AI. It comes from the AI technology called deep learning. Deep learning algorithms teach AI how to solve problems when given large sets of data. These deepfakes are used to swap faces and video and digital content to make realistic looking fake media. The problem with deepfake is that it can accuse an individual of doing something they did not do. This could be used to completely demolish or support one's political campaign with fake information. Deepfakes are already an existing problem, but with the development of strong AI, the quality of deepfakes will get much better than what it is today, which will be much more harder to detect and easy to fool the general public. Okay, so these were the potential problems that can occur with development of strong AI. And now I would like to wrap up my presentation with a video about deepfakes.
What are deepfakes? How do they work? And what can we do to protect ourselves against deepfakes? My name is Jean and this is Tech Explained. So, a deepfake is a photo, video, or audio recording that you might think is real, but is actually not because it was manipulated using AI. You may have seen this on TikTok, Instagram, or even YouTube, where the tool was used to replace human faces, manipulate facial expressions, and create entirely new faces and speeches that have never been seen before. I guess you've heard about the viral Tom Cruise TikTok videos, which were actually made by a video creator from Belgium. He made these realistic TikToks by combining traditional CGI and visual effects with deepfakes. And if you haven't seen that, then you might actually remember some of your friends and family putting their faces on celebrities with the Ukrainian app Reface AI. It created some pretty creepy, lifelike outputs that let you, for a hot minute, become Wonder Woman or Taylor Swift. The root of why this technology is so lifelike stems from its use of generative models, which try to learn the underlying data distribution of an image. Today, I'm here to give you the 101 behind how these generative model algorithms work. There are two things that you need to know about deepfakes. As of 2021, while there are many advanced algorithms that are used to create deepfakes, the most basic version uses something called a deep autoencoder. Now, while Reface used something like generative adversarial networks, also known as GANs, for their deepfakes, today I'll be talking to you about autoencoders predominantly because they're a little bit simpler in terms of their design. Now, an autoencoder has two parts that you'll need to know: the encoder and the decoder. Now, the encoder part of the autoencoder is used to discover the latent features of both your face and the face of the person that you want to face swap or make a deep fake with. These latent features are the underlying parts of your face that you can share with most human beings. For example, we all have eyes, a nose, and a mouth in roughly the same place. The encoder figures out what is similar between those two faces. We call the place where we put this information a feature set. And from there, we give the second part of the autoencoder, the decoder, the feature set of your face, which gets connected with, let's pretend, the celebrity decoder. That celebrity decoder is then used to reconstruct the celebrity's face on top of your original face. And voila, that's how deepfakes work. So to wrap it up, we use an autoencoder which has two pieces of the puzzle, the encoder and the decoder. The encoder compresses your face into basic latent features that make you uniquely you. We call these latent features the feature set, and the autoencoder then sends that information to the decoder. The decoder then does the heavy lifting and figures out how to merge and put a celebrity's face on top of your original face. Now, with simpler AI models, it may still be possible to spot the difference between a deep fake and a genuine image. Often, deepfakes might have inconsistent eye blinking or lesser definition in some facial features. And if you're overlaying a female face, then there might also be a mismatch in earrings. However, the newer versions of deepfakes are becoming able to learn these subtle features, including how to copy and imitate the original video's lighting. The truth is, while you might think that deepfakes are relatively benign and they can be successfully deployed for commercial use, deepfakes unfortunately can also be used for exploitation. Not only can people use deepfakes for revenge, but they can also use them for disinformation and ultimately undermining public trust. Thanks so much for watching this video. If you guys found this helpful, then definitely click a like and subscribe to my channel. My name is Jean and this is Tech Explained, a video series where I explain difficult things around us using simple and understandable language.
Hi class, this is the Hlaing from Team Gideon again. I'm gonna discuss about the conclusion of this strong AI presentation. To be concluded, we have presented the introduction, summary, and pros and cons of the strong AI. Actually, artificial intelligence is very broad. That's why we specifically focus on strong AI, which is the artificial general intelligence. I said in the introduction that it is very far away to get a strong AI, but it is getting closer to getting artificial general intelligence more than ever. For the first time in human history, we have AI that is smarter than a human, like AlphaGo, AlphaZero. Computers, Elon Musk said that now computer is actually smarter than us now. Question to think for the I have the question to think for the audience. What will the audience think about the AI? What AI will corrupt in the future and uncontrollable? Where human be labels or machine? I have a tip for that. For actually, we are losing to AI in chess and Go play already. What more can AI will be able to perform in the future? Will AI be better than human? How should we train our next generation to be able to control AI and successfully alive? And statistically, when drive an automated driving car, it has a larger possibility to happen an accident than drive the car manually, but injuries are less serious. So this is a work in progress. Nobody knows what will happen in the future. Every day, a lot of tech companies are researching the AI. So in the future, where AI have the emotions, Robot from the iRobot movie has the heart that will allow it to, have the emotion. But that is highly unlikely in reality. So please let us know about your answer in the discussion box. And then in the next slide, I will show the answer according to my research for these questions. So please tell me, guys, that you guys agree with our answer or not. So my answers are, will AI be corrupt and uncontrollable? According to CBS Insight, that would never happen. Even now, AI is changing our civilization from law to what we eat every day. If it is corrupt, then we already are long, gone already. Where human be the labors of machines. Actually, humans are already labors of machine long times ago. Think about Uber, Lyft, DoorDash, and all kinds of applications which command a lot of people to do their job. What more AI can perform in the future? For example, if you watch my Netflix, you can watch any script you like with a virtual actor. So someone predicted that will happen in the 2050. So movie were created just for you, just right away. Where AI be better than human? According to the debate of Jack Ma, Alibaba founder, and Tesla founder Elon Musk, Jack Ma said that AI will never be better than human because it is impossible to replace the human with AI because he said that scientists cannot even make a mosquito yet. So let alone human to replace a human. So how should we train our next generation to be better at AI? According to Jack Ma, he said that we should train our kids to be better at art, something that AI cannot imitate. When Jack Ma said that, Elon Musk obviously, disagree with that because Elon Musk he is like a science guy, so he want the kids to be better at science, not at the art. So another question is that where AI have the emotion. According to Olivia, AI will never understand the emotion, but AI can only mimic the emotions. So this is the end of our presentation. Thank you so much for watching all the way, guys. Thank you so much. So this is all the work cited that we did. This is a work cited for the introduction. This is work cited for the summary. This is work cited for the benefit of AI, strong AI. This is a reference for the potential problem of the strong AI. Thank you so much, guys. Thank you. Goodbye.